An overarching problem we've seen with safety is that safe enough has to include avoiding risk hotspots. A common talking point for safety for an embodied AI system is you say, well, it's safer than a human operator. And so our car driver is safer than a human driver because human drivers have these problematic behaviors. Maybe our aircraft pilot will be safer than a human pilot who makes mistakes. Maybe we'll have better outcomes than a radiologist reading medical imagery because the machine doesn't get tired and doesn't make mistakes, and so on. And so people will say, well, we want to look at the net outcomes, and if the net outcomes are safer, then it's a safer system. And there's certainly an appeal to this. Now I'm going to give some very hypothetical examples, and I stress the hypothetical to make the point. If you say, well, on US roads, there are about 40,000 people killed every year, and if computer drivers were 100% of the cars and they reduced it from 40,000 to 10,000, boy, that'd be a win, because 30,000 few people ever dying. And there's a compelling logic to that argument. But in practice, we're probably not going to see 3-to-1, 5-to-1, 10-to-1 changes. We're going to see, at least at first, very small changes for a number of reasons. And we're also going to see there's more to it than just the numbers. You can say, sure, this computer driver is 10% safer than a human driver, but there are other types of risks that are going to be unacceptable. And so here's some examples of risks. What if there's specific unsafe behaviors? What if robotaxis keep having crashes into emergency vehicles at accident scenes and hurt emergency responders? What if they transfer risk onto the vulnerable? What if the number of fatalities cuts in half, but all of the fatalities are pedestrians? So no one inside a robotaxi ever dies, but the number of pedestrian fatalities triples or quadruples. And now what you have is lots of pedestrians dying, but the people in the robotaxis are safe. I'm going to say that will be a socially problematic situation, even though the total number of fatalities went down. What if there's harm due to embodied AI negligence? What if every single mishap that results in a death or an injury comes when the embodied AI system breaks the law? What if every single fatality involves running through a red light and hitting a pedestrian? That's not going to be okay. What if there are negative externalities? One example we saw in San Francisco was robotaxis parking in firehouse driveways so the fire trucks couldn't get out in case of an emergency. Now, no one ever pinned down a fatality or an injury due to that, but it's a problem. They can say, well, the robotaxi was just being safe. It was doing a safety shutdown. Yeah, I get that. But a human driver would be very hard pressed to justify parking in a firehouse driveway, but the robotaxis were doing that more than once. What about compensating for other mistakes? You can say, well, our embodied AI system behaved in a way that was according to the law. It wasn't negligent, but somebody else made a mistake and we failed to prevent it. A crash is a crash, and if you fail to avoid a crash, you might have a higher mishap rate, even though it's never your fault. And there's also personal and psychological safety. What if a robotaxi dumps a rider out in a really bad neighborhood at 2 a.m. instead of delivering them to their spot? There was no crash, the person wasn't harmed in a mishap, but that still could result in issues for that person. This list of things other than net safety that do matter for safety changes how you have to look at safety. And when there's a human operator present, you can say the human operator is responsible for all these kind of risks, for avoiding these risks. But once you take the human operator out, which is usually the goal of embodied AI, is to get rid of the human operator or to greatly reduce their responsibilities, someone has to take care of these higher level safety concerns. To do that, you need to do more than say we're looking at the net losses. You need to actually identify various stakeholders have risk hotspots they're in charge of. The fire department says you're not allowed to block fire trucks, and I don't care if it's hard to prove anyone died from that. You're still not allowed to do it. And so a single risk metric of fewer fatalities or fewer injuries is not going to be enough. Instead, there are a bunch of constraints on acceptable behavior, and those constraints exist whether or not they are reflected in the net loss rate. You have to obey all the restrictions, all the constraints, and once you're done, then you can optimize whatever you want. One of those constraints is very likely to be fewer fatalities and probably fewer injuries, but it's not the only constraint. This is a fundamental rethink of how we have to look at safety once the human operator is taken out of the loop.